going to be so much faster than you.
We'll see. We'll see.
Okay, Dave, this is a straight race between you and Phil. 500 metres, you ready?
Yeah, you ready? Yep. Okay, 3, 2, 1. Come on! Just a little break. Give it up, boy. Doggy paddle. Yeah, I'm alright. Winner.
Yeah, nice one, Phil. Well done.
Oh, it doesn't look like Dave is much of a rower either. And I bet the graph shows us that as well. So let's have a look at Phil's first. Let's have a look at his distance time graph. And we can see that in the first leg of his journey, he has travelled 200 metres in 50 seconds. And that's at a constant speed of 4 metres per second. And moving on to his second leg, he has travelled 300 metres in 50 seconds. And that's a constant speed of 6 metres per second. And let's compare that to Dave's. Let's have a look. Oh dear, Dave. Well, we can see that in Dave's graph, he's got 2 sections that are straight lines, and neither of these are actually as steep as Phil's. So it's pretty clear that Dave was slower throughout the race. Now that is what too many crisps can do to you.
Okay, you started slower, you travelled less distance, and you didn't even finish. You are pathetic, man.
But I was faster.
No, how can you be faster and still lose the race, Dave?
Have a look at the graph around 1 minute, and I bet you I was going faster than Phil was.
All right, I'll take a look, but I think you might be wrong.
Right, well let's have a look at how fast Dave was going at about a minute. At a minute, that's 60 seconds, which is this point. And at this point, the graph is a curve. So what we need to do is place a tangent on this curve and find out where that tangent is the steepest. Now, if we draw a right-angled triangle onto our tangent, that means we can find out the speed at that point. Now, our triangle joins the coordinates 60, 60 and 100, 320. And as you can see, the triangle has a height of 260 metres and the time is 40 seconds. So we can use the speed distance time formula to work out the speed. So that's 260 metres divided by 40 seconds, and that gives us 6.5 metres per second. Now let's see if Phil was ever going faster than that. Oh, well, his fastest speed was 6 metres per second. Incredibly, Dave was actually right for a change. Amazing.
Right, I've got some news for you. At 1 minute, you were rowing faster than Phil. In fact, it was the fastest that either of you travelled at any point in the race.
Yes! I told you I was faster than you.
All right, on your bike.
Sorry?
You know, get on the exercise bike, let me beat you.
Oh no.
So what do you need to remember about distance time graphs? Well, the steeper the graph, the faster the object is moving. And remember, if there's a flat horizontal line, then the object is not moving at all, it's still. To work out the speed of an object, you need to draw a triangle so that you can look at the change in distance and the change in time over that particular section. And to work out the speed, of course, you use distance divided by time. So in this case, we've got 100 divided by 20, which gives us 5 metres per second. But if you've got a curved graph, you can always find the speed at any particular point by drawing a tangent onto the graph and then working out the gradient of the tangent. And the point where the tangent is the steepest, that is where the object is going fastest. But if it's Dave, don't expect your tangent to be that steep.
Oh, more of a swimmer.
Yeah. I prefer running.
Yeah, the squash is all right.
Tennis.
Racquetball.
Volleyball.
Pool.
Ballet.
bene.